to give you a brief of what we are doing is that when we are dealing with NLP, we usually first have to build a vocabulary as shown over here, that parse. Whenever a text comes to an NLP pipeline, this is the architecture of a NLP chatbot pipeline, which is an application of NLP. Now, when the text comes, you first have to tokenize it. Now, when you tokenize, you get tokens, which are essentially words and punctuation and emojis. Now, with those words, this is example of what will happen with those tokens in a sequence of steps. You get tokens, you get tag tokens, which means part of speech tagging, such as you label each word, whether it's a noun, adjective, or verb, and then you build a syntax tree like this over here. Like from good morning Rosa, you would build a syntax tree like this, uh, and then entity relationships, knowledge base. This is an overall high level view of what happens in an NLP pipeline with respect to building a knowledge base. But otherwise, if you want to build a knowledge base or a vocabulary, which is collection of tokens, then after this step, I'll show you. So normalizing. So if you are joining for the first time, that will be a bit of a challenge. But we discussed tokenizer in the previous session, and it's essentially what it means is that you scan the text, and you take out tokens from it. And a token is basically a symbol or a word or something like that. Over here with NLP, the tokens are essentially each single word. And once you have all the words with you, you build a vocabulary. Now, once you have started with the step of building a vocabulary, what is the next step? Next step that comes is that you want to improve your vocabulary. And how do we do that? By normalizing your vocabulary, because when we normalize a vocabulary, we reduce its size, and that is important to the performance of an NLP pipeline. We also normalize our vocabulary so that the tokens that mean similar things are combined into a single normalized form. Third reason why we normalize is that it improves the association of meaning across different spellings of a token or n-gram in your corpus. And fourth is, again, reducing your vocabulary can reduce the likelihood of overfitting. And how do we now normalize? It's through case folding. Case folding is such that you might have a name such as Joe Smith. Now, if you have a name called Joe, if you do a case folding on it, it will become Joe Smith, right? Now, that would mean that if you are dealing with we'll come to what's the problem with this in a little bit. But right now, the important thing for you to remember is the way to normalize data is through case folding, aka normalization. And the second is stemming. Stemming is that you are given words such as, if you're given a word such as housing or houses, you essentially do is remove the ing from house and remove the es from the house. So, and then you decide that it is essentially means that the word is HOUS, the base word for it. Stemming has some rules. Stemming works through rules, and those rules are predefined by a person named Porter, who worked extensively only in writing the logic of how a stemmer should work. And the algorithm most NLP pipelines use to stem for as part of doing stemming is through that Porter's algorithm only. Now, in that, it will be, if you want, you can also check it on the internet. Porter's stemmer, and Porter's stemming algorithm. It is the first. It teaches you. It is a rule-based approach to stemming. And how does, okay, now stemming, this was stemming, this is lemmatization. A point that we discussed in previous session was that uh, difference between stemming and lemmatization, which was that for grammatical reasons, documents are, this previous session we spoke about how do we differentiate between stemming and lemmatization. It's that the goal of both stemming and lemmatization is to reduce inflectional forms and sometimes derivationally relative forms. But in stemming we apply rules of spellings, and in lemmatization we get into the depth of what a word might mean, in its in English. And so when you are doing stemming on your vocabulary, how would it affect the precision and recall? Precision and recall are basically the way to analyze the performance of a search engine. Now, uh, uh, this is for, if I would have to explain recall, it is basically that you have five uh, candies in a bag, and if you put your hand in and if you are able to take out all of the candies, the recall is 1. And if you're able to not if you're able to grab only one candy from the bag and take it out, your recall would be 1 by 5. And precision is that, suppose there are 5 blue candies and 5 black candies in a bag, and I ask you, pick out red candies, and let's say you pick out 2 candies, one is black, one was red and one is blue, right? So red and blue candies are there. I ask you to pick out two red candies, and when you pick out 2 candies, one seems to be blue and one seems to be red, then your recall would be 1 by 5, and your precision would be precision would be 1 by 2, that only 2 of the recalled elements were correct. And how does it affect, so how does stemming affect precision and recall of a search engine? uh, so it says that broadening of search result would be a big improvement in recall score of a search engine. Yes, it would retrieve more results and recall would improve, but it will greatly reduce the precision of your search engine. That means while you are retrieving results, you would also retrieve a lot of wrong results with it, which are false positive. Now, lemmatization is that if you have access to so what you do in lemmatization is that you are aware of what a word might mean, and you you try to club those words together so that they are different spellings, they contain different spellings, but they essentially mean the same thing. So you try to reduce your vocabulary by clubbing such words together. Now, lemmatization and its use in the chatbot pipeline. When we are doing these sessions on understanding, analyzing, and generating text, we would be essentially talking with respect to a chatbot. And how does lemmatization affect affect our chatbot pipeline? Any NLP pipeline that wants to react the same way for multiple different spellings, which is essentially handled by a lemmatizer of the same basic root word, can benefit from lemmatizer as it reduces the number of words you have to respond to and the dimensionality the dimensionality of, okay. So if you use a lemmatizer, it makes your model more general. For example, it would respond in the same way to all of these variants of word chat. And likewise, it would also respond in the same way to the word bank, banked, or banking. No, not with lemmatizer, but these would be mean the same, treated the same way by a stemming pipeline, but not by a lemmatizer, because lemmatizer would also look at the meaning of those words. So lemmatization is potentially more accurate way to normalize a word than stemming or case normalization, because it takes into account a word's meaning. Lemmatization and POS tagging. POS tagging is part of speech tagging, where you tell, when you pass the input to a lemmatizer, you also pass a second argument to it, which tells the lemmatizer what the part of speech of that word is. For example, as we see here, if you're using NLTK and its wordnet lemmatizer, what if you pass it some words such as better only? By default, the default part of speech for better is noun. If you don't specify POS, it will assume that the POS part of speech tagging tag for the word better is noun. And with, if you say that better is a noun and you use lemmatizer on it, it would return you better again. But if you specify that by better you meant adjective, it will return you good, which is correct. And we also see some more examples here. For example, if goodness is a noun, it returns goodness only and does not uh, do any change to it. Now, in the next few slides, we'll be playing around with the sentiment analysis package called VADER. VADER stands for Valence Aware Dictionary for Sentiment Reasoning. VADER is a rule-based approach towards doing sentiment analysis. And as of NLTK version 3.6, NLTK uses VADER for sentiment analysis. We look at a code snippet. We don't have the extensive mechanism of how VADER works, but for the sake of knowledge, we would like to tell that it employs a rule-based approach towards a problem of towards solving the problem of sentiment analysis. Now, in sentiment analysis, when we do, what kind of rules does it employ? It essentially has a lexicon. Lexicon, by lexicon, we mean that it knows if some word is present, or it marks words with a sentiment. For example, this emoji, which we can see over here, has been marked negative, which is
Assis, I just wanted to know what the VADER exactly do
okay.
in the previous slide.
Very,
Yeah.
very high level. What does VADER do? Okay, I'll show you. 1 second. You let me know if you are able to see my screen.
Yeah, I'm able to see. And one more thing, I just wanted to know, like, will you also be going to show me some coding part as well?
Yeah, I'll show you in code only.
Okay. Like I'm totally new to the NLP part because
Yeah.
I'm just started transition my into the
Yeah.
machine learning or data science.
Okay.
So everything is new to me. Like yeah, data analysis part and machine learning part, I'm aware of it, but I'm not like frequent worker on NLP.
Okay.
Yeah.
1 second. That's okay with me. I am referring a previous code snippet of mine, Python code Vader. So LTK. 1 second. It's taking a bit of time to do it. Okay, NLTK we have imported. You are familiar with Python?
Yeah, yeah. In the like data analysis and machine learning part, like
Yeah, yeah,
I
that's
can apply models and do some analysis, but in terms of like automation part, I'm not that much of expertise actually.
okay. So, okay, give me a second. If we need to import VADER sentiment is also required, but NLTK testing. 1 second. Okay, VADER.
Ashish, which Python ID you use for the coding?
I, as a data scientist, I work with Jupyter notebooks and Jupyter Lab. IDE, there are a number of IDEs, but you can use it's
Yeah,
IDE. Visual Studio Code is not exactly an IDE, but you can
yeah.
use Visual Studio Code also. So we have installed VADER Sentiment, and we would try to do some. I'd show you some example over here in this window. Uh, Python import from VADER sentiment dot VADER sentiment import sentiment intensity analyzer. This much is clear. And if we
Yes, yeah, it is in.
repeat what it is doing in the, okay, there is a mistake as SA in SA dot lexicon has no attribute lexicon intensity analyzer. Okay, SA equals to sentiment intensity analyzer. SA dot lexicon. So yeah, it shows over here that it has marked words with some kind of sentiments, and it is using a rule-based approach. As we saw over here in this slide, VADER is a rule-based approach, and over here we saw a code snippet. So what essentially VADER does is it tells you VADER is a package for doing sentiment analysis, and it is a rule-based approach, and it has got a vocabulary where it has kept uh, what it would, if for example I'd also run it on a polarity score. Okay, SA dot polarity underscore scores, and then we pass it as text. This one, right? You understand this is for this is an emoji, text-based emoji for saying that I feel sad. I think if I would introduce some kind of spaces, that would make it more clear. So it says that it's negative, and over here we can see that its sentiment is roughly its overall score that has been a number that has been assigned to it is minus 1.9, and it is sure that it is not neutral, it is not positive, it is sure it's negative. And as of compound, it does some calculation on these three parameters and gives you a compound rating as well of what it thinks of this overall statement, because there are some spaces also over here. Now is roughly this gives you a working knowledge of what VADER is. If you want to go into more depth, I'd share this with you in the chat. And there's a research paper also published for this. The algorithm was presented in a research paper. It should be available on the internet. But to give you a working knowledge of what VADER does, it does the sentiment analysis. And the drawback of VADER is that it looks only at the words it knows, which are about 7,500 words. And what if so where I'm coming from prepared this where I'm coming from, the question that remains to be answered by VADER is, what if you want all the words to help add to the sentiment score? And what if you don't want to have? There is another algorithm that we look at in the future sessions, but this time these questions are not answered by VADER. What if you want all the words to contribute to the sentiment? What if you want to if you want to add a bunch of custom words to the dictionary? Or if you don't understand the language, you won't be able to work this way the way VADER does, because it depends on a dictionary, a lexicon, where you are defining what sentiment a word holds. And to give you a brief idea why, so VADER is a good start for you to pick up it. We have shown over here that it maintains this kind of vocabulary, like ye has got positive score of, has been put with a tied with a score of 2.4, and that means it's a word that means that the person is happy. If you look at the word worthless, it has been given a negative score of 1.9. So overall it knows what to do with the input that you give it, and it works on the basis of that. But VADER is not industry standard, even though it comes with NLTK as well, because when we were doing some comparative analysis of VADER and text blob, we figured it out that VADER and text blob were not giving that good of results in comparison to a much in comparison to an industry standard encoding mechanism called BERT, which was presented by Google. And BERT, when we encoded our input with BERT, we got very good results of, not very good, but better results of zero point 0.7 or something around. Yeah, these are through BERT, and weighted is zero point 0.6, micro is zero point 0.7, while with VADER, the scores were the accuracy of 0.557. We got an accuracy of 0.557. So that is mostly what we had for today. Now, if you have any questions, this is the time you should ask. Rahul.
Yeah, I do have some questions, but firstly, I